Hello friends, this video is on Unit 8.5, adding and subtracting with unlike denominators. Well, if the denominators are not alike, they have to be. You cannot add two fractions together unless they have the same denominator. So your first task will be to make the denominators the same. So we jump into number 1. This is just taking us back to when we were younger, just to remind us how to do things. So the idea is we want the denominator to be 6. We want the denominator to be 6 because 6 is the first number that both 3 and 6 go into. So the first thing I ask myself after I decide the denominator is going to be 6 is I look at this 3. Whoops, don't know what's happening there. It's thinking for me. I look at this 3, and I don't want it to be 3. I want it to become 6. So if I don't want it to be 3, if I want it to become 6, I'm going to have to multiply this by 2. Because if I multiply this by 2, 3 times 2 is 6. But I can't do something to the denominator of a fraction without doing it to the numerator of the fraction. Because basically what I'm doing is I'm multiplying the entire fraction. I'm doubling it. I'm doubling the entire fraction. So then when I do that, I have 1 times 2 is 2. And I didn't have to do anything to the other fraction, so this is going to stay plus, and then the other numerator is 5. And then 2 plus 5 is 7. So my answer comes out to be, so I add these together. I add these together and I get 7. 6. That's my answer. And if you type that in your calculator to see if I'm correct, you'll find out that I am. So then, I'll go over here. First thing I ask myself is what would the common denominator be? The common denominator would be 20. The first number that 4 and 5 both go into is 20. In other words, the least common multiple is 20. So, I want this number to become 20. Gosh darn, what is going on? I want this number to become 20. It's not 20. What do I have to multiply to make it become 20? I have to multiply it by 4. So if I have to multiply that by 4, I have to multiply this by 4 also. That's going to give me 8 over 20. Then this is a minus sign, so I'm going to put a minus sign. And then the next question I ask myself is, okay, this is supposed to be a 20 also. So if that's supposed to be a 20 also, what do I need to multiply it by? Well, I need to multiply it by 5. That'll turn it into 20, but if I multiply the denominator by 5, I have to multiply the numerator by 5. Basically, I'm multiplying the entire fraction by 5, and that's going to give me 15. And if you step back and look at this, if you look at only this part of the problem, that part of the problem will reduce to what you had originally, 2/5. Likewise, if you look at this part of the fraction, it reduces to this fraction. So you know you have done it right. Okay, so now that we've done that, we just need to do the math. And the math says to take 8 minus 15. And 8 minus 15 is negative 7, and the denominator is 20. And voila, we are finished. Yes, everything is good. Okay, well that's great. That had no x's in it. So let's come here. Not a problem. First of all, I will tell you that because we're now doing algebra instead of 5th grade math, I would wrap this numerator in a parenthesis, and I would wrap this numerator in a parenthesis. Just to remind yourself that they go together. They are a couple. 3x plus 2 is a couple, and 4x minus 5 is a couple. They go together. It's a binomial. They are together. They are in a container when they're in the numerator. All right? Then, we're going to do exactly what we did before. We have, the denominators are 4 and 8. So the common denominator of 4 and 8 is 8. So we ask ourselves, we say, self, if I want this 4 to become an 8, what do I need to multiply it by? And we're going to multiply it by, whoa, hello, I'm still in the highlighter mode. Let's get out of that. I'm going to multiply it by 2. So I'm going to multiply this by 2. Well, nobody multiplies by 2 in the back like that. So let's multiply I probably should have done that at the beginning, but I didn't. You'll survive. So I'm going to multiply by 2. All right, well, what does that mean? That means I'm going to take 2 times 3x, and I'm going to take 2 times 2. And when I do that, 2 times 3x is 6x, and 2 times 2 is 4. Then I'm going to look at the next fraction and realize this is an 8. That's exactly what I want. Here's where you got to be really careful, friends. This is where you need, and sometimes, and I encourage people to write this down so they can see it. If they need to, this is a -1. Everybody see the -1? We are distributing a -1. We are distributing, or we are wanting the opposite of that binomial. So that is negative 4x, and a -1 times a -5 is a +5. And I can almost guarantee you, if you mess this problem up, it's because you have the wrong sign right there. This negative sign right here is asking me for the opposite of both these numbers. So we want the opposite of 4x, which is -4x. We want the opposite of 5, which is +5. Then we're going to combine terms. And friends, when we combine like terms, we have 6x minus 4x is 2x. And 4 plus 5 is 9 over 8. So if you got lost on that, if I went through that too fast, think about this. 6x minus 4x is 2x. And 4 and 5 are 9. And so that entire thing is your answer. Okay, that was fun. Let's do this one. All right, we need a common denominator. We need a common denominator, and the common denominator is going to be 9x to the second power. This first denominator needs to become a 9x squared. So what is he missing? He is missing a 3. Oh, again, same mistake twice in a row, Mrs. Leonard, stop that. So we're going to have to triple this fraction. If we take 3 times 3x squared, we get 9x squared, which means we need to do it up here. And 3 times 7 is going to give us 21. And again, if you pause for a moment and look only at these, you will see that they would reduce to this. So you know you've done it correctly. All right. Then the next thing you ask yourself is, what does this need to become this? Well, it needs another x. Because now if you look at it, it says 9x squared. So it says 9x squared, and 1 times x is x. So we're going to go plus x. And there's nothing else you can do with that. So that is our answer. Again, you cannot reduce x's because there is a sign that is a monomial 21 plus x. They go together. They're hooked up. If you need to remind yourself of that, I don't know, you might want to put that in parentheses to remind yourself you cannot cancel that x. All right, next. Okay. This is a binomial. It is a unit, x plus 2. And this is a binomial. It is a unit, x minus 4. So our common denominator is going to be x plus 2. Just be neater. X minus 4. So we want this denominator to look like this. What is it missing? It is missing. It is missing the x minus 4. That's what it is missing. We want, oh, that was too fat. Okay, next we want this denominator to turn into this denominator. So what does he need? He needs an x plus 2. And what you multiply the denominator by, you have to multiply the numerator by. Okay? So now we're going to do that. So now we're going to distribute. We're going to take 3 times x. We're going to take 3 times negative 4. We're going to take positive 5 times x. We're going to take positive 5 times 2. Then we're going to add like terms. 3x and 5x are 8x. Negative 12 and 10 are negative 2 over the denominator of x plus 2, x minus 4. And that entire thing, my friends, is going to be your answer. I think, do we want to do, okay, I think we might. I think we might with that answer. Gosh darn. Probably should have talked to my team. This is factorable. Nothing can happen to it. However, for what we're going to use it for in the future, we might want it in its factored form. I don't know. I'll have to think about that if that's what I want. And your teachers will have to think about that. Maybe the Algebra 2 PLC will discuss that and see how we want that answer. But what we would use it for in the future, it would need to be in factored form. So I'm thinking, I hate to say it. I really do hate to say it. But I'm thinking this is the most proper way to write the answer. Okay? But we'll talk to the team. We'll get back to you guys. I'm sure your teacher will tell you what they want. And by then I will have decided what I want. Alrighty, so here we go. Common denominator. Common denominator is going to be all of this and all of this. Okay? So then the first question we ask ourselves is, how do I turn this into all of this? And I do that by multiplying this by 2x minus 5. And then the question comes, how do I turn this into all of this? And the answer to that question is, I am going to multiply all of this by 3x minus 1. Now, I will tell you, friends, right here, this is going to be a lifesaver. This negative sign right here you need to write it right in front of that negative 4x. So that when you distribute that negative 4x, you distribute the negative. That right there will save you from doing this problem again, frankly. All right, so let's distribute 6x times 2x is 12x squared. 6x times negative 5 is negative 30x. Negative 4x times 3x is negative 12x squared. And negative 4x times negative 1 is plus 4x. The denominator is still 3x minus 1 over 2x plus 2. Now when you combine like terms, 12x squared minus 12x squared cancel each other out. That's nice. Negative 30x and 4x are negative 26x. And so that entire thing is our answer. Okay. We have an issue right here. And this issue is, that is the difference in two perfect squares. That binomial factor that quadratic binomial can be factored. There's the words I want. That quadratic binomial can be factored. So the very first thing we're going to do is we're going to go x over x minus 2. So nothing there changed. Minus 8 over, and the factored form of that is x plus 2, x minus 2. And you notice what I did? I pulled that negative sign up so that it looks like a negative 8, because that's going to become key here in a minute. All right, now we need a greatest common factor. The greatest common factor, or I'm sorry, we need a common denominator. Wow. We need a common denominator, and the common denominator is x plus 2, x minus 2. So we ask ourselves, what does this need to become this? And what it needs to become that is an x plus 2. So I'm going to multiply numerator and denominator by x plus 2. Now, fortunately for us, this is already this, so it needs nothing. So we're ready to go. So we're going to distribute, and x times x is x squared, and x times 2 is 2x, and negative 8. But here's the deal. Now, some of you have already seen it. Some of you are all like, crap. Alrighty, so this is factorable. So now we're going to factor that. So when we factor it, it factors to x plus 4, x minus 2. Because the factors of negative 8 that add up to positive 2 are 4 and negative 2. The denominator remains what it was, x plus 2, x minus 2. And now comes in that assignment we did a couple days ago. Those two reduce each other. So our final answer is x plus 4, x plus 2. And that is our answer. We cannot reduce. We cannot reduce. That is our answer. All right. So, now, step 1 is to factor anything that can be factored. Step 2 is to get a common denominator. Step 3 is to combine like terms. And if we need to factor and reduce again, we will. But step 1 is to factor. And you're like, what are we factoring? This right here is factorable. So if that right there is factorable, this stays what it is. And this becomes x minus 3, x minus 3. Get a common denominator. The common denominator has to be this entire denominator. So the common denominator is x minus 3 times x minus 3. Then the question becomes, what does this need to become that? And what it needs is an x minus 3. Then the question becomes, whoops, eraser, Mrs. Leonard. What does this need to become that? Unfortunately, it doesn't need anything. He's already good to go. So we only have to distribute the 1. The x times x is x squared. X times 3 is negative 3x plus 5. And fortunately, there are no factors of 5 that add to 3. So we are done. So we are finished. And so all we need to do is say that we know we're done. This is our answer. Because a quadratic cannot be factored. Alrighty. So the first thing we do now is we look to see if somebody can be factored. And this pesky thing right here is the difference of two perfect squares. He can be factored. So the rest of this, though, can stay exactly the way he is. So we don't have to do anything with that. So let's just write it down again. So there it is. And then we're going to go minus fraction bar, x plus 2, x plus 2, x minus 2. Huh. Yeah, nope, we're not going to. Okay, moving on. Now we need to get a common denominator. And the common denominator is right here. So the common denominator is x plus 2, x minus 2. That's the common denominator. So then the next question you ask yourself is, what does this denominator need to turn into this denominator? And it needs an x minus 2. So we are going to multiply this by x minus 2. And we are going to multiply this by x minus 2. Then we ask ourselves, we say, self, what does this need to become this? And what it needs is an x plus 2. So we're going to multiply this by x plus 2. We're going to multiply this by x plus 2. And then we're going to ask ourselves, self, what does this need to become this? And it already is that, so it needs absolutely nothing. I would caution you that this negative sign right here means that we are going to want the opposite of this entire thing, okay? So it might be good to pull that up so you see it. Totally your call. Okay, so the next thing we're going to do, friends, is we are going to multiply these two things together. Now, if you understand your factoring, which is suspect, but if you understand your factoring, you have x times x, which is x squared. You have x times negative 2 and negative 1 times x. So basically, negative 1 and negative 2 are negative 3. So you have negative 3x. And then what you would do is you would multiply negative 1 by negative 2, which would give you positive 2. So you unfactored them, if you will. Okay, this next one is a plus sign. So that is 3 times x, which is 3x. And that is 3 times 2, which is 6. And this is negative x. And this is negative 2. So now we have this mess. So now we're going to combine like terms. This is your only squared term. So you have x squared. We have a negative, whoa, highlighter please. We have a negative 3x. We have a positive, 3x and a negative x. Those combine to negative x. And we have a 2, a 6, and a negative 2, which combine, purple please, to 6. And that's factorable. Of course it is. So that is factorable. Let's put the denominator back. The factors of 6 that add to negative 1 are 3 and negative 2. So that will factor to x plus 2, x minus 3, and the denominator is x plus 2, and x minus 3. No, x minus 2. Okay, I did that rather fast. I'm going to slow that down. This factored becomes this. Maybe this would be easier if I would have written it beside it. I don't know. I don't know that that makes it better. And then, friends, these cancel. Boom, boom. So final answer, x minus 3, x minus 2. All right, here we go. So we're going to factor first. Okay, so this factors. So we have 6 over x times x minus 2, greatest common factor. This factors. Negative 1, x plus 2, x minus 2. I like to raise that negative sign up, so I remember that whatever's happening in that numerator, I really want its opposite. All right, need a greatest common factor. Greatest common factor has to be all of this and this. That contains everybody. Everybody. So, our denominator is x. Why do I keep saying greatest common factor? Least common multiple. Common denominator would be the best word. X plus 2, x minus 2. Okay? All right. We need this to look like this. So what is he missing? He is missing the x plus 2. He is missing the x plus 2. So we need to multiply that fraction by x plus 2. Why did I write a 6? Okay. All right. We now need this denominator to look just like this denominator. What is he missing? He's missing the x. Now we're going to distribute. 6 times x is 6x. 6 times 2 is 12. And negative 1 times x is negative x. We're going to write that in standard form so we can see if it can be factored. Oh, no, we're not. We're going to combine like terms. Hello, Mrs. Leonard, focus girlfriend. We're going to combine like terms. So 6x minus x is 5x. And then we have a 12 as our only constant. And then our denominator, we're going to leave in factored form. And then this is our answer because you can't do anything with that numerator. All right. Are there more? There are more. Woohoo! Okay. So friends, we are going to factor. And the first thing that we see that's factorable is this guy. No, he's not. Thank goodness. Yay. Is this guy. All right. So that first fraction is x squared minus 5 divided by x plus 2, x minus 2. And that is the only thing that factors. So the other piece is just going to get written down. Excellent. So now we need a common denominator. And as it turns out, as luck would have it, this is our common denominator. So our common denominator is x. Look at that, I used the right words this time. Common denominator, x plus 2, x minus 2. So this first fraction needs nothing. The second fraction, however, this, to look like this, needs an x minus 2. So we're going to multiply this by x minus 2. So that leaves us with x squared minus 5 plus x minus 2. Then we combine like terms by saying, ooh, we're going to write it in standard. The only terms we have that are alike are these two. So we're going to write it in standard form. Standard form is highest power first, x squared. Next power, constant. And then we have x plus 2, x minus 2. And that will not factor, so that's going to stay as it is. All right, that's the answer for that. And I think we have one more problem, friends. Thank you for those of you who hung out. You guys know you don't ever have to watch all of these, right? Okay. We're going to factor. And this guy has the greatest common factor. So we have x divided by 2 times the binomial x plus 4 minus 8 over. This guy is factorable. He has the greatest common factor of x, which leaves us x plus 4. Our greatest common factor, our common denominator has to have the x plus 4 in it, has to have the 2 in it, and has to have the x in it. So our common denominator is 2x, x plus 4. So then we ask ourselves, we say, self, what does this have in it? What do we need to make it that? And what we need to make it that is simply an x. And then we ask ourselves, we say, self, what does this need to look like this? And our response is simply needs to be multiplied by 2. So then, x times x is x squared. Negative 8 times 2 is negative 16. But, ding, 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 you guessed it, that is the difference of two perfect squares. So now, my friends, this can be factored. Oh, I really can't answer that right now. So we're going to factor that. And we're going to have x plus 4 and x minus 4 over 2x, x plus 4. And then this is going to cancel this. So our final answer is x minus 4 divided by 2x. And I think that we have reached the end. There you are, my friends. Thank you very much. Good luck. Ask your teachers if you have questions. Why won't this turn off? There we go.